This video describes how to measure porosity of propagation substrates in plug trays. Porosity refers to how much of the cell volume in a tray is made up of water, air, or solid after it has been irrigated and drained. We will cover how to measure porosity in your substrate. Our goal is to help improve your consistency in growing quality young plants. The space in a propagation tray is filled with solid substrate particles, air, and water. When a tray is irrigated and drained, the largest pores are filled with air, and the medium pores are filled with water. The smallest pores are filled with water, but the water is tightly held to the substrate and not available for plant roots. The substrate on the left has larger particles, and therefore larger pore spaces between the particles. That means the substrate will hold more air and less water than the substrate on the right. Roots need air to grow, and under heavy mist irrigation, the substrate on the left may produce more rapid root growth. However, there is a balance. The substrate on the right would be more prone to waterlogging under mist, but plants may go longer before they need to be irrigated. Disease is likely if the substrate holds too much water, leading to anaerobic conditions, meaning low air. If particles are too coarse, the plant root ball may not hold together, and plants may dry down too quickly. In this case, the media holds too much air and not enough water. To test porosity, you will need 2 plug trays with 128 or fewer cells per tray, both with and without your substrate. You will also need a water basin, tape, scale, saucer, and blade. Now we are ready to make measurements. You will need to know the empty tray weight to zero out weight calculations. You will also need to measure the cell volume. Plug the drain holes with tape and fill the cells with water to the same level as would normally be filled with substrate. Weigh the trays using a gram scale. Each milliliter of water weighs 1 gram. Now we will get ready to measure the air porosity. To do this, saturate the filled tray section by gradually submerging the container into the water basin until the water level is about 1 centimeter below the top of the surface. Once fully saturated and the substrate surface glistens, remove the section from the sub-irrigation basin. Quickly transfer to a saucer and scale. You will measure the tray weight when it is saturated, and again after the tray has drained for 15 minutes. The water that drains out will be from the large pores, and represents the air volume in the tray. So the difference in weight in grams before and after draining equals the air volume. Air dry the tray section. The difference in weight between the air-dried tray and the irrigated and drained tray represents the water holding capacity, also called water porosity. You can now calculate both the percent of the cell volume that is air porosity and the percent water porosity. Whatever volume is not accounted for is filled with solid particles. We have a porosity calculator for cell tray substrates app in Back Pocket Grower to help you make these calculations. Here are some example data in the porosity calculator for cell tray substrates app. This shows the output from the Back Pocket Grower app. We also have detailed step-by-step bulletins, one for trays that are filled with loose substrate and another for stabilized substrates. We also have an app and bulletins for testing porosity in finished plants grown in pots. You can compare typical values for porosity in commercial greenhouses against your own seedling plug or cutting propagation substrate. You can root well in many substrates. The key is to match the porosity of your substrate to your irrigation practices, crop, and climate. Thanks for tuning in. Visit backpocketgrower.com for more information.